Assalamualaikum. Today the topic on which I will discuss is about the DLD lab number 6, that is implementation of multiplexer and demultiplexer using different ways on or different methods on Quartus using Verilog HTL. Verilog HTL is basically a type on which we perform different simulations. It is present in both Model Sim and Quartus. So the objective of this lab is basically we will implement multiplexer and Demux using softwares like Quartus. I've already used. I'll just show you the outputs. Procedure, we will leave this part. Now if we see the as I above mentioned here, we will I will tell you how can we implement multiplexer and demultiplexer using different methods. So here is our first method. It is basically logic gate level code. This is our logic gate level code, and here we can see this is our module named A01, which consists of output, input 1, input 2, in 3, in 4, control 1 and control 2. We have given output as out, input as the rest, and we have given a wire at not control 1, not control 2, wxyz. Now we have implemented two not functions on control 1 and control 2, and we have implemented four and functions, and we have we can say that we have implemented four AND gates, where at the wire wxyz input 1 2 3 4 not control 1 not control 2 not control 1 control 2 control 1 control 1 and control 2, and then we have used a OR gate for our final output, that is for out and the four wires, and then we have ended the module. As we can see here, we have given all of these inputs. Control 1 and control 2 are given as the NOT gates. This we can see these circles, these four circles that are not control 1 and not control 2. These are our four AND gates, and I have above mentioned that how we can implement those functions, and how we did that and what we wrote, and then the final output is given by OR gate. This is its output waveform. First of all, we should see that if we give input 1 a certain value of its waveform, so the next waveform or the next wave's input will be double of the previous. As we can see here, this is the smallest, this is large, this is the larger than the previous, and the largest, and this is our output. Then the second method is the assign level code, that is this module A01, which is given by assign level code is basically the logic level implementation code. So here we have the above steps are same as the first method, just we have to assign the logic, that is input 1 and not control 1 and not control 2, or these are for four OR gates and four AND gates and one OR gate. We have used single operator OR gate as we can see that four AND gates are used for our AND gates are used for the output as the input of this OR gate. So we can see this in our schematic diagram, and this the output waveform is same as the previous output waveform. The third method is basically the case statement. This is basically the case statement, that output 1 is equal to input 1, output is equal to input 2, output is equal to input 3, and output is equal to input 4. And these are our case statements, and this is our default, that if none of these values are performed, then the default will be displayed as please check control bits, and the case will be ended with end case and end module. And this is our schematic diagram, and these are our two input values given by these values, and this is our output, and the output wave is same as the first above two. The first example is the assign level implementation code as the first method. You can see here this is all the same. Case statement. This is basically the case implementation code. This is case implementation code. This is its waveform and this is its schematic diagram. And this is let's leave this. If we come on the example 3, this is if statement code. We have done similar operations as previous up to here, and then we have begin an if statement, that is if select value is equal to 0, q will give this value. If select is equal to 1, q will give the value of this address, and similarly the rest. This is its schematic diagram and this is its output waveform. The fourth example is conditional statement. We will assign q, and these are the conditions, that if select is equal to this, select is equal to this, and all of this, then give this output, or this output, or this output. This is our schematic diagram, we can see here, and this is our output. Now we will write and simulate. We will see the simulation already present here, and the Verilog codes of the 1 to 4 1,4-D multiplexer using gate level method, logic statement, case statement, and if statement. This is gate level implementation. We have in the multiplexer case, we have seen that there were 6 inputs and only 1 input, but here there are 4 outputs and 3 inputs. So as you can see here, these are our 3 inputs and these are our 4 outputs. This was our gate level implementation code. The second one is the logic level. We have assigned this, and these are our logics. We have written some logics over here, input 1 and control 1 and control 2, and similarly the rest. And this is how we perform the logic level implementation code. The third one is the case implementation code. It is basically the third one. Module is given as this. Output are 4, inputs are 3. We have used case as this, that w is equal to in1, x is this, y is this, and these are our case level statements. And the default statement is please check control bits, and we have ended case and module. And this is our schematic diagram, we can see here, and the output waveform is same as the logic level and the assign level implementation code. And the last is if statement implementation code. We have applied if statements here, and as you can see, these are our statements, and this is our schematic diagram, this is our output waveform, and that's how we have performed a lab of Verilog HDL simulation on multiplexer and demultiplexer of Quartus.